Okay. Got some problems?
Yep. Alright, first one is 2x squared plus 12x minus 30 equals 0.
Okay. The problems we've had in the past were just expressions, whereas this is an equation. So the completing the square process is a little bit different.
Okay.
Actually, it's not. No, we're going to complete the square entirely on one side of the equation. So, in essence, what's our first step?
Wouldn't it be to like take out a greatest common factor in this one, or?
Yeah, but really our first step is to put parentheses around those first two terms.
Okay.
Now, it's not so much a greatest common factor. That's not really what you're doing, is you are factoring out 2. And it wouldn't have to be a greatest common factor. I can make that an 11 and I would still have to factor out 2. Okay?
Right.
But, in other words, what you have to do to complete the square is make sure that the x squared term has a 1 in front of it.
Okay.
What's left?
X squared plus 6x.
And I leave space here on purpose. Leave the 30 there. So everything's copacetic now. It's the same as we started with. What's next step?
Oh, it would be to, wouldn't it be plus 36?
Take
Or wait.
half, well, first of all, take half of that x coefficient and square it.
So 9.
Okay? And it's always added. Now, the moment I do that, how much did I add to the left side of the equation?
9.
Times 2.
Or 18.
Okay. So, since I added 18, I got to subtract 18. Now it's perfectly balanced.
Mm-hmm.
In other words, now this is the same as what I started with. Okay?
Mm-hmm.
Now what? Why do we complete the square?
To make it a whole square?
To make
So it'd be
a linear term squared. You can always do that when you've completed the square. That's why we do it. So what goes in the parentheses here?
it would be x plus 6. Or 3.
Whatever you got when you took half of 6.
The 3.
Notice that when I square this, the last term is going to be 9.
Mm-hmm.
So you can always use that as a guide. In other words, x plus 3 times x plus 3, if you FOIL it out, you end up with a 9 at the end. Okay? And now you have to combine those two terms.
Mm-hmm.
What are those?
That'd be negative 48.
And now you have it in perfect vertex format. Notice the format we have it in. A times x minus h squared plus k. That's vertex format. So where's the vertex?
Vertex would be negative 3, negative 48.
Good. Now, do they ask you to solve this?
Yeah.
Solve it by completing the square, right?
Yes.
Okay. So once we get it into vertex format, we could actually have done this a couple of ways. I could have moved the number to the other side. I chose to leave it on the same side because it's nice to know you can get it into vertex format when you need to. However, to solve this, I want to move that 48 on the other side. Let's do that first. Let me do it this way because I'm running out of room. So that's equal to 48, right? Now we can solve this relatively easy. How do we do it?
We're
going to end up solving it by taking the square root of both sides. But we can't do that until we have that completely isolated. How do we isolate that?
You divide divide everything by 2.
So now we have x plus 3 squared equals 24. Now what?
Square root that.
Okay, so we got x plus 3 equals...
X plus 3 equals...
Hold on, before you answer. What do the first words out of your mouth need to be whenever you're taking the square root of both sides?
Plus minus.
Okay. What is it?
Well, square root of 24 is like...
Okay, yeah. I'm not worried about you simplifying it yet. Let's get to the final answer. Okay? So, now I'm going to change colors to show you where I'm at. So what's x equal to?
X is equal to plus minus square root of 24 minus 3.
Okay. And I'm going to put the minus 3 first. The reason I put it first is notice what this looks an awful lot like. Answers you get when you use the quadratic formula. Right?
Okay.
In other words, the quadratic formula is negative b plus minus the square root of stuff over 2a. Well, those answers always come out looking like that. They may have a denominator, but they don't always have a denominator. Okay? Now simplify root 24. Let's get a good answer here. This is not a great answer because we haven't simplified root 24. What is root 24 equal to?
Do not know.
Okay, let's talk about simplifying radicals.
Yeah, they haven't taught us that yet.
Really?
Yeah, we're learning it next unit, but for some reason they haven't taught us.
Well, let's give you a little head start because it's actually pretty simple. Let's make sure you get off to a good start with it.
Okay.
When you have a number in a radical, your goal is to find factors of that number where one of those factors is a perfect square number. Over here on the left, I'm going to write the perfect square numbers. You can see that that's 2 squared, 3 squared, 4 squared, so forth and so on. Okay? So, can you factor 24 where one of the factors is a perfect square number?
No.
Why not? 4 goes into 24 6 times.
Oh, I thought you meant like, okay, no, yeah, never mind.
That's what I mean. In other words, whenever you have the square root of a number, here's what I mean. The square root of a times b is always equal to the square root of a times the square root of b. So that's what I'm doing, is I'm separating the a and the b. The a and the b were 4 times 6. So that's equal to the square root of 4 times the square root of 6. Now, that's useful that there's a perfect square number there because now that becomes a integer, 2. There's your answer. 2 root 6. Now,
Okay.
simplify root 6.
Well,
Think
or
of factors of 6.
well,
What
3
are,
and 2.
okay. However, are they perfect square numbers?
Is it what?
Are either of those a perfect square number? 2 or 3?
No.
No. So we don't do it. In other words, we never do this.
Right.
The only time we break it down is if I can find a perfect square. How about that one? Can we do that one?
No.
Well, how about, there's that perfect square number. See what I'm doing?
Yeah, I think.
Well, let's go back if you're not certain. I've got square root of 8. So whatever I can factor 8, I can write. That's the same as the square root of 4 times 2.
Right.
That's the same as the square root of 4 times the square root of 2. And that is the same as 2 square root of 2. So I'm never writing square root of 8 as an answer. I'm always reducing it to that. Square root of 6, I'm always writing as square root of 6. It doesn't make any sense to turn it into 2 radicals instead of 1. So you only simplify it if you can find a perfect square factor. And the best way to really do it is to start with your number and start trying to divide by some of these perfect square numbers. Okay? If you can find a perfect square number that divides into it, then it's not simplified. How about that?
Mm-hmm.
No? Tell me whether that's simplified or not.
Well, no, it's not. It would be
What would it be?
5. It'd be square root 5, square root 2.
Remember, you only do that if one of those numbers is on this list over here. And I'll put the first one up there. Except I don't want to write that 1. It's not really a useful information. In other words, 2 is not on that list and 5 isn't on that list. Therefore, we do not split it into square root of 2 times square root of 5. It is the same thing as square root of 2 times square root of 5. Don't misunderstand me. But it's not a simplification. I would never do this.
So why do you why do you have to do it in the 4, 9, 16s, 25s, 36, and 49s?
Because when you get one of those factors to be this one of these numbers over here, the square root of it is always a whole number. Here's
But why would
you may not realize this.
I'm just why does it have to be?
Yeah, no, I understand your question. That's an irrational number. That's an irrational number. By irrational, I means I cannot write it as a fraction. This is not. That's the number 2. This is irrational. That is irrational. That is irrational. That is irrational. This is not. That's the number 3. Okay?
Mm-hmm.
So it doesn't do any good to take square root of 10 and turn it into the product of 2 irrational numbers. It's a true statement, but it's not a simplification. And you don't really need to understand why. You just need to follow that rule. A lot of rules in mathematics, it's pretty hard to understand why. It's like, why can't you divide by 0? Well, there's a lot of good reasons why you can't divide by 0, but you don't really need to understand why you can't do it. You just need to remember you can't do it.
Right.
Okay? So when we have radical numbers, the only time we can simplify it is if we can divide by one of these perfect square numbers. And this list goes on forever, but usually is all you need to do is consider those right there. If it's not divisible by one of those numbers, then it's probably not simplifiable.
Right.
Okay. All right. We'll do more of that after you get classroom instruction on it, but hopefully that'll help make it more understandable when you do get classroom instruction.
Okay.
Let's go back and do another complete the square, or solve an equation by completing the square. What else you got? We'll do this one slightly different this time.
All right. 5x squared plus 10x minus 30
Equals 0.
Yeah.
This time I'm going to move the 30 over to the other side, just to show you that you can do it either way. Okay? Now, first step again.
Greatest common factor.
Remember, it's not the greatest common factor, and really the first step is to put parentheses like that, leaving enough space right there to complete the square.
Okay.
That's always the first step. Put parentheses around the x squared and the x term. Now, I can see why you call it greatest common factor, but it really isn't. Notice the greatest common factor is 5x.
Right.
I'm not going to do that. I'm going to factor out whatever the coefficient in front of the x squared term is. It's not a greatest common factor.
Right, but are you allowed to...
Yes. Even if this said 9, here's what would happen. Same thing, right?
Right.
Now, completing the square, I take half of the middle term, which is 9/10. I square it, which is 81/100. In other words, I can complete the square even if I have fractions. Doesn't matter.
Right.
The problems they're giving you don't have fractions, but it's important to understand that. You're not taking out the greatest common factor. You're not even taking out a common factor. You are merely dividing everything by that coefficient of the first term. So I'm factoring out 5. But I'd be factoring out 5 even if that 10 was a 9, okay? Or an 8 or an 11 or anything else. 10 does not have to be divisible by 5 is what I'm trying to say. In this case it is. So we're left with this, right?
Right.
All right, now finish it by completing the square.
All right, so...
Step by step. And do it out loud so I know what you're doing.
Okay, so cut 2 in half and then square it.
Hold on.
That's
Take half of 2. What do you get? In other words,
1.
work methodically. Get one number and then do something with it.
Okay, so...
What's half of 2?
1.
Okay. What's 1 squared?
1.
Okay, so I'm going to write plus 1. Now what do I do to balance it?
To balance the... Oh, you gotta add 1 on the other side.
Well, you got to add how much to the other side?
Oh, 5.
There you go. And you do add it. Remember when I was doing everything on one side? I did the opposite. In other words, I would have subtracted 5 if that 30 was still on the left side of the equation. But I moved the 30 over, so now I'm balancing out on the other side of the equation. I'm not balancing out on the same side.
Mm.
So because I added 5 to the left, I got to add 5 to the right. Okay. So now tell me what to write. What's the next step on what to write?
Um, you would write, uh, so 5 x squared, or
Hold on.
5x,
What goes in the parentheses?
the x, and the 1
X plus 1.
plus 1.
Not just x1. It's x plus 1 because that can be a minus sometimes. If that was a minus 2x in the middle, then it would be x minus 1 squared. In other words, x plus 1 squared is this quadratic that's in the parentheses.
Right.
And you will always, 100% of the time, be able to take it and write it as a linear term. That's what that is a linear term squared. Okay.
Right.
What's the other side?
Equals 35.
Okay. Next step.
Square root everything.
Now,
Or no,
isolate it.
divide everything by 5.
What's that?
Divide everything by 5.
Okay, that gets rid of the 5 on that side. Whoops, how come my eraser didn't work? There we go. Get rid of the 5 over there and change that to a 7, right?
Right.
The reason I'm doing it like this because I'm running out of room to write. Next step.
So then it would be square root everything.
Okay. Give me the next line.
It would be x plus 1 equals plus minus square root of 7.
Good. Finally, what's x equal to?
X is equal to negative 1 plus minus square root of 7.
Very good. Notice that is two answers. First answer is minus 1 plus root 7. The second answer is minus 1 minus root 7.
So I wouldn't be able to simplify this because 7 is prime, right?
You're right. 7 is prime. You definitely cannot factor prime numbers. Or you can't simplify radicals of prime numbers because it doesn't have any factors. It can't have a factor from our list of perfect square numbers.
Right.
Okay. We can do another one real quick if you want.
Let me see if I have one.
Okay. I'll bet you can do it quick also. I'd like to see you do one more. Just let's make sure you can do it all on your own.
That's 3x squared minus 12x minus 9.
So I'm going to take that minus 9 and put it on the other side. I think it's a little more understandable to do it this way rather than leaving it on the same side. Okay. Now, give me the next line each time. I'm going to try to say as little as possible.
Alright, so the first thing, it would be 3x squared minus 12x and then parentheses 3x squared minus 12x and then a spot, blank spot.
I've done that. Okay. That's not hard.
And then the next thing is take out a greatest common factor. So it would be 3. So it'd be then 3 parentheses.
Not a greatest common factor. I just want to point that out. What the next thing you're really doing is you're factoring out the coefficient of the x squared term. That's what the next step is.
All right.
I know it's similar to greatest common factor, and it kind of looks like greatest common factor, but it definitely is not.
Right.
Okay? Because if that 12 was 11, I wouldn't have a greatest common factor, but I would still have to factor out 3.
Right.
Okay, so what's the next line?
So it'd be 3 parentheses x squared minus 4x.
And this is
And
where I
then
really make sure I leave room.
it would be equals 9. Then half of 6 or half of 12 is
No, not half
6
of
or
12. Half of
half of
4.
4. Half of 4 is 2, so it'd be -2 squared, which is 4. So you'd have to plus 12
Well,
on both
no, hold
sides.
on. Let's not get confused here. Inside the parentheses is always that.
Right, and then but you got a plus 12
I
out.
got to add 12 to the other side because when I wrote that plus 4, I was really adding 12 to the left side.
Mhm.
I'm adding 4 times 3. Okay, next one.
Mhm. It would be 3 parentheses x squared
No,
or x. Wait, what?
remember what you're doing. You're turning this into a linear term that we're going to
Oh
square.
yeah, x. All right, so it's x minus 2
Okay,
squared, and then
okay.
it would be plus 4.
No,
Uh
no, this whole
oh.
thing is equal to this. It
Uh huh.
always will be 100% equal to it because we have gone through the process of completing the square. And the reason we complete the square is so that we can write it as a linear term squared.
Yep, and then it would be equals 21.
Okay, next line.
The next one would be uh okay, then it would be or no, it'd be x minus 2
Hold
equals
on, hold on, hold on. We're not ready to take the square root of both sides yet.
right, you gotta square the parentheses.
Got to get rid of that 3. That 3 is not being squared.
And then equals 7.
Okay. Now
And
we're
then
ready to take the square. You're never
yep.
ready to take the square root of both sides until you get just whatever's in the parentheses squared.
Yep.
Got to get rid of everything else. Okay. Next
So
line.
then it would be x minus 2 equals plus minus square root 7.
Next.
Then the next line would be um 2 plus minus square root 7.
Good. Very good. Math is just a matter of memorizing the method. It really is. In other words, is all you just did was memorize a method of completing the square. And it allows you to solve the equation.
Mhm.
Okay. Blake, I will talk to you tomorrow. I think we have a session tomorrow night at 7:30 if I'm not mistaken.
Yep.
Talk to you then.
Okay, bye.
Bye-bye.